A polygon is a closed shape with straight sides. For example, these shapes here are all polygons. You can see they're made with straight sides, and the shapes are closed. These two shapes here are not polygons because they're not closed. You can see we have some gaps here. These two shapes are not polygons either because some of their sides are curved. We can split polygons into two categories. We have polygons that we call regular polygons and also irregular polygons. These polygons are regular. What makes them regular is that all of their sides are equal in length. And additionally, all of the interior angles are equal in size. If either of these statements are not true, then the polygon would be irregular. For example, this rectangle here, all of the interior angles are equal, but the sides are clearly not equal in length. This rhombus here, all of the sides are equal in length, but the interior angles are not equal. And for these two polygons here, the interior angles are not equal, and nor are the sides equal in length. If we have a regular polygon with 3 sides, we call this an equilateral triangle. If we extend it to a regular polygon with 4 sides, then this is a square. If we add a 5th side, then this one would be a regular pentagon. If we add a 6th side, this one would be a regular hexagon. A 7th side means we end up with a regular heptagon. An 8th side, now we have a regular octagon. If we add a 9th side, we have a regular nonagon. And if we go up to a 10th side, we have a regular decagon. For your exams, you need to recognize and learn the names of all of these apart from a 7 and a 9-sided shape. So you don't need to know the regular heptagon or the regular nonagon, but you do need to know all of the other ones. This doesn't mean they won't come up in questions, but if they do, they'll probably be named for you. You may already know that the angles inside a triangle add up to make 180 degrees. You may also know that the angles inside a 4-sided shape, a quadrilateral, add up to 360, but many people don't know why. The reason it's 360 is we can split a quadrilateral into 2 triangles like this. Each of the angles in these triangles will add up to 180 degrees. So we have 2 lots of 180 degrees, which is 360. We can extend this idea to shapes with any number of sides. So if we increase the number of sides again and look at the angles inside a pentagon, we can split the pentagon into 3 triangles like this. Each of those triangles will have 180 degrees in them. So this time we have 3 lots of 180 degrees. 3 times 180 is 540. So this means the angles inside a pentagon add up to 540 degrees. Let's do another side and go for a hexagon. This time we can split the shape into 4 triangles. Each of those will have 180 degrees in them, and then if we add up all of those 180 degrees, we get 720. So the angles inside a hexagon add up to 720 degrees. So the first shape, the triangle, had 3 sides. And it might seem a little odd to say this, but it was one triangle. The second shape was a quadrilateral which had 4 sides, and we split that one into 2 triangles. The pentagon had 5 sides, and we split that into 3 triangles. The hexagon had 6 sides, and we split that into 4 triangles. Notice how the number of triangles is always 2 less than the number of sides. So for the triangle, it had 3 sides, and if you subtract 2 from this, you get 1 triangle. The quadrilateral had 4 sides, and if you subtract 2 from that, you get 2 triangles. The pentagon had 5 sides, if you subtract 2, you get 3 triangles. And the hexagon had 6 sides, and if you subtract 2, you get 4 triangles. So the number of triangles we can split a shape into is always 2 less than the number of sides it has. We can extend this now to look at shapes with any number of sides. For example, this shape here. Now if we use our original strategy and split this into triangles by drawing them, this one gets quite messy. There are loads of triangles. Instead, we can just count up the number of sides. This shape has 15 sides. If we subtract 2 from this, we know without drawing them, there must be 13 triangles. Each of those triangles will have 180 degrees in them, so we do 13 multiplied by 180, which gives you 2,340. So all of the angles in this 15-sided shape must add up to 2,340. We have a special name for this total. It's known as the interior angle sum, because it's the sum of all of the angles on the inside of the shape. We can create a formula for this based on what we've looked at so far. Let's say that we have a shape with n sides. To find the number of triangles, we subtract 2 from the number of sides. So this is n subtract 2. And then once we have this number of triangles, we just multiplied it by 180. So this formula here will allow you to work out the interior angle sum of any polygon of any number of sides. Let's have a look at how we can do this in some questions. So for the first question, we're going to work out the interior angle sum of a decagon. Earlier we said a decagon had 10 sides. So using this formula, we want to do 10 subtract 2, so 10 becomes the n, and then multiply this by 180. If you do this with a calculator, you end up with 1440. Or we could work out the interior angle sum of a polygon with 24 sides. So all we do is replace the n in the formula with 24, so it's 24 subtract 2 multiplied by 180, and this gives you 3960. Sometimes exam questions may require us to work out the interior angle sum, for example this question here. For this question we're looking to find the angle x. We can see that this shape is a pentagon since it has 5 sides. We can work out the interior angle sum of the pentagon using the formula. Let's replace the n in the formula with a 5. So it's 5 subtract 2 multiplied by 180, which gives you 540. This means all of the angles on the inside of that pentagon must add up to make 540 degrees. Now I can see 3 of them, and we also have one in the top right which is a right angle, and a right angle is 90 degrees. If we add up the 4 angles that we have, 95, 121, 90 and 104, we get a total of 410. But we know that all 5 of the angles must add up to make 540. So if we subtract this 410 from 540, we'll find the remaining angle. 540 subtract 410 is 130. So the size of angle x must be 130 degrees. Now let's try another example like this, but slightly more complicated. So we've got this irregular polygon here, and we're told that angle ABC is 3 times angle BCD. And we've been asked to find the size of angle ABC. So angle ABC is this one, and angle BCD is this one. Let's call angle BCD x. Now since angle ABC is 3 lots of angle BCD, it's 3 lots of x, and 3 lots of x is 3x. Next we want to work out the interior angle sum. This shape has 6 sides, so we need to do 6 subtract 2 multiplied by 180, which will give you 720. This means all 6 of these angles must add up to give 720 degrees. So let's add up all of the angles. Now this time 2 of the angles are algebraic, but that's okay, we can still add those up. So let's start with those two, 3x plus x, and then we'll add in all of the numerical angles we have. All of this must add up to give you 720, the interior angle sum. This 3x plus 1x will give you 4x. If you add up all of these numbers here, you get 496. So we've got 4x plus 496 must give us 720. This is now just an equation to solve. If we subtract 496 from both sides, on the left we'll get 4x, and if we subtract it from the right, we end up with 224. Then we can divide both sides by 4, on the left this gives you x, and on the right 224 divided by 4 is 56. So we find that x is equal to 56. But this isn't the answer to the question. The question wanted us to find the size of angle ABC, which is this one here, and we labelled that one as 3x. So if we know that x is 56 degrees, 3x must be 3 lots of this. So 3 multiplied by 56 gives you 168 degrees, and that is the answer to the question. Next we're going to take a closer look at some regular polygons, like this regular pentagon here. If we calculate its interior angle sum by doing 5 subtract 2 multiplied by 180, we get 540. This means all of the angles inside this shape must add up to make 540. But since it's regular, remember that all of these angles must be the same size. So we can actually find out the size of each of these angles by dividing the sum by how many angles there are. The sum is 540 and there are 5 angles, so 540 divided by 5 gives you 108. This means that all of these angles must be exactly 108 degrees. We can do this for any regular polygon. For example, this regular hexagon here. This time we do the interior angle sum, 6 subtract 2 multiplied by 180, which gives you 720. So all of the angles must add up to make 720, but there are 6 of them and they're equal in size. So we can find one by doing 720 divided by 6, which gives you 120 degrees. So each of these angles is 120. Since these angles are on the inside of the shape, we call each of them the interior angle. So we can now create a formula for the interior angle of a regular polygon. We started by finding the interior angle sum, and then we divided this by how many angles there were, which is also the same as the number of sides on the shape, which we use the letter n for. So we just divide the interior angle sum by n. Let's see how we can use this formula in some questions. So for this question, we're given a regular polygon, and here it is, and we're asked to work out the size of angle marked y. So since this is a regular polygon, we can use the interior angle of a regular polygon formula at the top. We need to know how many sides this shape has, and if you count them, there are 12. So we're just going to replace the n in the formula with 12. So we have 12 subtract 2 multiplied by 180, which would normally give us the interior angle sum, but since we're trying to find just one of the angles, we divide this by how many angles there are, which is 12. If you type this into the calculator, you'll get 150 degrees. So the answer for y is 150 degrees. What about this question here? Work out the interior angle of a regular decagon. We said earlier that a decagon had 10 sides, so we're just going to replace the n in the formula with 10. So we do 10 subtract 2 times 180, which would normally give us the interior angle sum, but we want just one of the angles, so we divide it by 10 since there are 10 of them. If you type this into your calculator, you'll get 144 degrees. And let's try this question here. Work out the interior angle of a regular polygon with 30 sides. So all we do here is replace the n in the formula with 30. 30 subtract 2 times 180 divide by 30. Typing this into your calculator will give you the answer of 168 degrees. So this is how you find the interior angle of a regular polygon, and it only works if the polygon is regular. Next we're going to take a look at exterior angles. If we bring back this regular pentagon, this angle here was known as the interior angle, because it was on the inside. So most people tend to think that this would be an exterior angle because it's on the outside. But unfortunately, that's not how we draw an exterior angle. To create an exterior angle, we extend the length of one of the sides. It's then the angle that this extended line makes with the next side along. So this angle here is known as the exterior angle. And you could do this with any of the sides of the shape. So all of these are also exterior angles. So how would we go about finding the size of one of these angles? Well, if we take all of these exterior angles and bring them together like this, you'll see it makes a circle. In a full turn, there are 360 degrees. Since there were 5 angles and they're all equal in size, we could find the size of one of them by doing 360 divided by 5. This will give you 72 degrees. So each of these exterior angles here for a regular pentagon is 72 degrees. Let's have a look at how we can apply this to other shapes. So what if it was a regular hexagon with 6 sides? Well, here are all of the exterior angles, and if we bring all of those together, they once again make a full turn of 360 degrees. Well, for this one, there are 6 equal angles, so we divide 360 by 6, which gives you 60 degrees. So each of these angles here is 60 degrees. Notice how it doesn't matter how many sides the shape has, the exterior angles always add up to 360. This means we can easily write a formula for calculating the size of the exterior angle. So the exterior angle for a regular polygon is just 360 divided by how many sides it has, which we called n. Let's have a look at how we can use this formula to solve some problems. So first of all, we've got work out the exterior angle of a regular octagon. Earlier, we said that an octagon had 8 sides, so we just need to replace the n in the formula with 8. It's as simple as 360 divided by 8, which gives you 45 degrees. And what about if we were asked to work out the exterior angle of a regular polygon with 15 sides? Well, we'll just do 360 divided by 15, which gives you 24 degrees. So working out the exterior angle of a regular polygon is very straightforward. We just divide 360 by however many sides it has. Let's bring back the regular pentagon from before. We worked out its interior angle at 108 degrees, and we also found the exterior angle, which was 72 degrees. If you add together 108 and 72, you get 180 degrees. So for this shape, the interior angle plus the exterior angle makes 180 degrees. And this is not surprising since they're both angles on a straight line. In fact, this formula, interior angle plus exterior angle equals 180, works for any regular polygon. We can use this in some questions to help speed up the process. For example, if we are asked to work out both the interior and exterior angles of a regular polygon with 18 sides. Well, the exterior is easy to work out. We just do 360 divided by n, where n is the number of sides, so in this case 18. So for the exterior angle, 360 divided by 18 gives you 20 degrees. So the exterior angle is very quick to find. We learnt a formula earlier for finding the interior angle. It was this formula here. So to find the interior angle, we replace n with 18, so 18 subtract 2 times 180 divide by 18, which if you type into your calculator will give you 160. But we can use this formula here at the top to speed up this process. If you already know the exterior angle, we can quickly find the interior angle because they must both add up to 180. So for this shape, the exterior angle was 20 degrees, so we can just subtract this from 180, which gives us 160, and that's a lot easier and quicker to do. Now there's one final formula that we need to cover for angles and polygons. If we take the formula for the exterior angle was 360 divided by the number of sides. If we rearrange this formula, then the number of sides must be 360 divided by the exterior angle. This formula can therefore be helpful in finding the number of sides a polygon has if we know its exterior angle. Let's have a look at how we use this in some questions. So the exterior angle of a regular polygon is 10 degrees. Work out how many sides it has. Well, to work out the number of sides, we just do 360 divided by the exterior. So 360 divided by the exterior, which in this question is 10. 360 divided by 10 is 36. So this shape must have 36 sides. Let's have a look at a slightly harder one. The interior angle of a regular polygon is 171, and we need to work out how many sides this one has. Well, the formula requires us to do 360 divided by the exterior angle, but in this question we were told the interior angle. But we do know that the interior plus exterior makes 180. So we can find the exterior by subtracting the interior from 180. So if we do 180 subtract 171, the interior, we find the exterior is 9 degrees. We can now use the formula at the top. The number of sides is 360 divided by the exterior. So 360 divided by the exterior, which is 9, gives you 40 sides. So far in this video, we've had 5 different formulas. We've had the interior angle sum, the interior angle of a regular polygon, the exterior angle of a regular polygon, the interior plus exterior is 180, and also the formula to find the number of sides. We're now going to look at how exam questions use some of these formulas. So here we have a diagram, and we're told it shows 2 regular pentagons and a regular polygon X. We're asked to work out the number of sides that regular polygon X has. So we're going to start with the fact that there are 2 regular pentagons, so these have 5 sides. We're going to work out their interior angles, which I've marked onto the diagram here in red. We'll do that using the formula for the interior angle. A pentagon has 5 sides, so we do 5 subtract 2 times 180 divided by 5. This gives you the interior angle of 108. You might remember that one from before. So both of those red angles are 108 degrees. Now if I mark on the interior angle of regular polygon X, so this angle here in green, we can work this out because all 3 of those angles are angles around a point, and angles around a point add up to 360 degrees. So if we do 360 and subtract both of those 108s, we find the green angle is 144 degrees. In this question, we're trying to work out the number of sides of regular polygon X. The formula we had for the number of sides was 360 divided by the exterior, but we've now found the interior angle of regular polygon X, so we need its exterior angle. We can do that using this formula here. Remember, the interior plus exterior must make 180. So if the interior is 144, the exterior must be 180 subtract this, which gives you 36 degrees. We now know the exterior is 36, so we can use the sides formula. The number of sides is 360 divided by the exterior, which is 36. This gives you 10, so the shape must have 10 sides. And that's the answer to this question. Let's try another example. So in this question, the diagram shows a regular nonagon, 2 equilateral triangles, and regular polygon Y. And we are asked to work out the number of sides that regular polygon Y has. We're going to do this by working out these 2 angles here. We'll start with the regular nonagon, the shape with 9 sides. To do this, we'll need the interior angle formula. Since it has 9 sides, we do 9 subtract 2, multiplied by 180 divided by 9. This gives you 140 degrees. And for the equilateral triangle, it's quite easy. We just need to do 180 divided by 3, which gives you 60 degrees. So we can mark both of these angles onto our diagram. Now we can work out this green angle here, in the same way we did before. The angles around a point make 360. So if we do 360, subtract 140 and 60, we end up with 160 degrees. So we've now found the interior angle of regular polygon Y, but the formula for the number of sides needs the exterior angle. So we'll use this formula once again to find the exterior angle. We know the interior one is 160, so if we do 180 subtract 160, we find the exterior was 20. We can now use the formula for the number of sides, 360, divided by the exterior, which is 20, gives you the answer 18. So this shape had 18 sides. Thank you for watching this video, I hope you found it useful. Check out the one I think you should watch next, subscribe so you don't miss out on future videos, and why not go and try the exam questions in this video's description.